My name is Ethan.
And my name is Colby, and we are the 2D liquid metal actuation team. This semester, we were mentored by Sage and had help from Nick, a previous member of the team. Over the past few semesters, the 2D liquid metal actuation team has made advancements in moving liquid metal in a 2D plane. The previous team was able to fabricate a 12 electrode square well, the liquid metal to actuate within, as well as implement a graphical user interface, or GUI, with buttons corresponding to each electrode. For this semester, we have been working on speed control, a braking system, and predefined paths for the liquid metal to follow. After this, we hope to create a GUI that will allow users to draw paths for the liquid metal to move along. Before we get into the results, let's go over how liquid metal actuation works.
Galveston at room temperature is a liquid and works as a liquid metal. So for our design, we use a solution called NaOH or sodium hydroxide, in which half a centimeter is poured into a 3 by 3 centimeter box. The liquid metal bead is completely submerged in the solution to prevent an oxide layer from forming. There are 3 electrodes along each side of the box. These electrodes are stainless steel strips that help to actuate or move our liquid metal in a way that we want it to, as liquid metal is pulled towards a higher voltage. An Arduino is used as the controller for these electrodes, which is programmed to send signals to the electrodes and tells them to turn on, off, how long to turn on, and at what voltage. In order to implement the GUI, we use a software called Qt Creator, which is a software that allows you to create and code your own GUI.
In terms of results, so far we have been able to implement a braking system by setting the voltage at the closest electrode to 6 volts. Doing this stops the liquid metal bead from hitting the wall. Additionally, we've begun writing predefined paths for stars, rectangles, and triangles. The code for these paths are currently being tested.
In the future, we plan on advancing our design to do user defined paths and eventually 3D actuation. Next up is the Microwave Simulations Group.
My name is Jacob Moritani.
And I am Glenn Manio.
Previously, in fall 2020, we worked on finding the capacitor design with the most potential to make a tunable capacitor using liquid metal. The first design we simulated was the interdigitated capacitors. Through a variety of designs and simulations, we found that both interdigitated and metal insulator metal capacitors, aka MIM capacitors, could be tuned to create around 5 times greater capacitance. However, the MIM capacitor required much less size to implement liquid metal into the design. Because of this, we were able to fabricate the design. Moving forward to spring 2021, we are currently focusing on developing our simulation skills and creating documentation. This will further assist in accelerating the learning process of simulating for the next generation. It is extremely tedious not to run headfirst into fabricating a device. However, simulations do not require materials and provide evidence if your fabrication is even correct in the first place. We plan to break this process down into simple painless steps to help develop the skills for these three simulators: Microwave Office, Axiom, and HFSS.
Using a simple ideal T-line model here, we can show the process of design in the three simulators. Microwave Office is the easiest to use and quickest simulator. We use this simulator to create ideal models and add parasitical effects from the substrate. Axiom is an included environment in AWR that adds more parasitics like airboxes to simulate a more realistic world. HFSS is the most complex simulator. However, this simulator can simulate the most parasitical effects, making the results the most similar to a real-life fabrication. In conclusion, our objective this semester is to understand the basics and gain proficiency in the three simulators using projects that can naturally progress through them. This will help us create documentation that will guide you students through the simulation softwares using the best methods and make it easier for them to fix any problems they encounter. Thank you.